This is reminding me heavily of the Large Hadron Collider. Do you guys know about that?
It's in the city of Colonel.
No, it's under Geneva.
Damn it.
Good guess, though, buddy. Good guess.
Border of France and Switzerland under Geneva, about 17 miles in circumference, excuse me.
Jesus
and
Christ, are you kidding me?
574 feet below ground.
Oh.
It was a bit of a project.
The largest scientific machine constructed in human history, basically. This is the biggest. So the purpose of this thing, this big hoop, is that they throw different particles at each other and smash them together and then record the impact, the collision, and then have to attempt to determine different laws of subatomic particles based on the impact of that collision between these particles. So usually it's protons and electrons that they shoot along these beams, these magnetically controlled beams, and they smash into each other, and then they record that result of that, what happens to the breakup of those protons and electrons into even further subatomic particles, quarks, muons.
Is it opposing? Is it a positive negative, or is it a positive positive? Like, so protons
It's two
and
separate
electrons.
particles. Well, they're smashing them together, so I don't think it has to do with their positive or negative charge.
Right. It's just
But is it an
different
actual
experiments.
smash?
Yeah, they
Like
whip
like
them. They're going around the 17-mile thing, whipping around and boom, right into each other.
Wow.
Like I said, the primary use for this is going to be to record the arrangement of subatomic particles after a proton, which is one of the smallest units of matter that we can conceive of.
It's a
even smaller
particle, I guess.
Even smaller than that would be muons and quarks and things like that. And then even smaller than that, they believe there are other particles, one of them being the Higgs boson.
Is that the God particle?
Yes.
Basically a further subatomic particle that would be from what I understand, and again, the physics on this gets extremely dense, but it would be, I guess, core to several different differing proton-electron configurations. That's something that, from these different variations, there's something that's the same within them, and they're trying to find this one particular particle which has a certain mathematical density, gravity. There's all these tetra electron volts, TeVs. So this was a huge undertaking. Initially was financed at $2.2 billion in 90-something.
Damn.
Chump change.
In the 90s, though?
Wow.
Yeah, it started in 98.
That's walking around money.
Currently at, I believe I saw the figure at 14 billion. They had to basically, upon further review and what they needed to have for these experiments to actually pull off, the number grew astronomically. And this is one of the largest science experiment undertakings that mankind has ever 32 different countries, 100 different universities and labs across the world.
Damn.
They have an entire computer network set up to record the immense amount of data that comes out of each individual experiment that they do. And these different universities have to collaborate and figure out what happened during these particle collisions.
Imagine compiling all of that data and then trying to track electron particles breaking up through all of your computer software.
Now stop.
In the 90s.
Right. You're a scientist. If you just imagine that.
That's what they dig. That's that's part of the game. I mean, having to sift through that data. It's basically panning for gold.
Mm-hmm.
You're just going through all the silt until you find that one little nugget where you see, the correlation that you're looking for. Boom, there it is.
Silt nugget.
Your colleague is like, I found it. Just walk over. It's like RDRT. Just shoot her in the head and take her gold nugget.
I got what I needs.
Shoot the Large Hadron Collider.
Yeah.
Dr. Smith, what are you doing?
So I found this interesting. First of all, a lot of this is off the Wikipedia article, which people don't like that. When you say that, it kind of sounds like you're going to Walmart for your information. However, I challenge you, any
backed.
one of you who thinks you know anything about anything,
It's
look
backed.
it up on Wikipedia and tell me that doesn't have more information.
Okay, if you're talking about a Kardashian, then someone might go and say, "Oh, and her butt is made of gold" or something. I mean, when it comes to actual science in there, why would someone troll it? You know, I mean, you can find science on there, and it's fairly solid, and it's cited.
I heard actually that her boat was made of gold.
It actually
Solid
is.
gold.
Solid gold.
Oh, I heard
Solid
it from
gold.
you.
That's true. Just now.
The purpose of the Large Hadron Collider was to solve several different quantum mechanic problems or theories, prove them out. And a couple of the ones that I liked were, is the mass of elementary particles being generated by the Higgs mechanism via electroweak symmetry breaking?
Oh, my fave.
Mm-hmm.
Right?
That old nugget.
So there was a
The favorite of mine.
there's a I guess a model of physics called the Standard Model, which basically subscribes to the existence of a Higgs boson particle, but hasn't been detected. We haven't had the science available to detect this actual particle, but mathematically it's been proven out. So that's part of the Standard Model of physics. There's also the Higgless model, which, you know,
Sexy.
So wait, the other one was like Schrodinger's particle. Like you're just like you're not really sure if it exists or not.
well,
But mathematically, they've
right.
never seen it, but mathematically,
correct, it
it
exists.
is.
And also the fact when you're dealing with quantum physics, there's a whole issue with when you observe it. When you observe it at a quantum level, you're changing it, and so it's that's not relativity. It's it just has to do with just the observation paradox.
In relation to Ant-Man, how far
Boom.
did he go with this?
Right up Thanos' butthole.
Hey, come on, spoilers.
Right?
Come on, even
Damn.
I know
Supposedly, some of these experiments are designed to at least start to prove out the initial multi-dimension string theories, I guess, that are out there, in that they want to account for the loss or gain of different subatomic particles or weights. And again, like going through this, it was just like sigma. This is 3.5 sigmas, which means it's not provable, but 4.5 was almost provable, and it's just like a lot of very dense physics stuff. But one of the interesting things that happened during the initial tests was they had what was called the Quench incident.
That's badass sounding.
Wow.
Yeah.
The Quench
And I had to
incident.
look for it.
We got X-ray, we got Quench.
September 2008, a magnetic quench occurred when
What
100
is that?
100 bending.
I'll tell you. I'll tell you right now.
Oh, you got a snort. I think that might be the first Fritz snort on that
No,
one, man.
there's been others.
That's a good one.
September 2008, a magnetic quench occurred when about 100 bending magnets in sectors 3 and 4, which, you know, those are the dangerous sectors. Right? Like, those are,
Oh man.
you gotta
Always.
be careful
always.
with those. An electrical fault tied to a loss of approximately 6 tons of liquid helium, which vented into the tunnel. The escaping vapor expanded with explosive force, damaging about 53 superconducting magnets and their mountings, and basically ruined the vacuum conditions of the actual pipe that they were beaming the particles through.
6
And-
tons of it got through?
6 tons. 6 tons initially with explosive force, and then an additional 4 tons, I believe, leaked out afterwards during the, like, after it had been depressurized or whatever.
So this shit was fucked all the fuck
Yeah,
up.
so, and this was,
Technically.
yeah,
Thank
exactly.
you.
The actual, like, official,
official papers.
the official CERN report was fucked all the way the fuck up, whatever that acronym is. Most likely the cause, the fault was a faulty electrical connection between 2 magnets, and that it created an arc between them. There was some type of power failure, created an arc which caused one of them to fail, and then caused the liquid helium inside to raise to a dangerous temperature, which it expanded, and then blew the whole shit all the way the fuck up.
Oh man.
All the fuck the way up. It'd be great if
All
newscasters
of it.
talk about, and then it blew all the fuck the way up.
So they
Back
were
to you, Jill.
They were down for 14 months repairing this, and it cost somewhere a couple billion, I believe,
Did,
Jump
to actually
change.
get it.
did anyone get killed?
Or
So
mutated.
one person did
Right.
die, but not during that the Quench incident. Jose Perea Lagas, a technician, was killed when a switchgear that was being transported fell on top of it.
Oh.
So, like, more of kind of just a failure of.
Oopsie daisy.
No, there's a little bit of an oopsie. I mean, a pretty serious oopsie,
An
but
ocean nightmare.
A death-causing oopsie. Death by oopsie.
Those happen.
and there were additional vacuum leaks that they detected and were able to repair without, like, too much damage to it. But that was, like, the main thing, the Quench incident, which kind of, you know, fucked everything up for a little over a year. So I thought this was interesting. There's a lot of, I guess, fear, misunderstanding about what was going on there. Some people thought it was, you know, this, like, super weapon.
Yeah,
they were
hell
they was
yeah,
gonna
I
make
did, man.
black holes
Come
or
on.
some
You're
shit
gonna
like
make
that.
a black hole in the middle of my Earth? Not on my watch.
At least if they're doing it in France, that's all right,
Why
right?
is
Like, I
it
don't
your
care.
Earth?
And your watch, like, when does your watch end?
Because I bought a handgun.
I guess that's how it works.
Start shooting into the Earth.
Not this time, Large Hadron Collider. So yeah, people thought it was going to make like black holes, or they were going to blow up the Earth, or whatever. But one of the more interesting results of one of these experiments was the creation of particles they called strangelets.
Wow, getting strange.
Strangelets.
Getting some strange.
I can tell you guys have been married for a while. Strangelets is a hypothetical. It's so I'm quoting from the Wikipedia article. Strangelet is a hypothetical particle consisting of a bound state of roughly equal numbers of up, down, and strange quarks. Which again, those are like the subatomic particles have those weird names like luck and charm and up and all that stuff. So, an equivalent description is that a strangelet is a small fragment of strange matter. Strange matter
It's
is
very vague and open.
Yeah.
strange matter is
Strange.
a particular form of quark matter, usually thought of as a liquid of up, down, and strange quarks. So even at the subatomic level, they're still like subscribing to these like physical, like, you know, solid, liquid, gas,
Right.
and the way that they manipulate each other or interact with each other. So I don't know. I forgot who the Greek philosopher was, but he talked about doesn't matter how much further down we look, it continues to get more chaotic.
Sounds almost like fractals, almost in a way, but fractals are organized where chaos is not.
That's
the thing.
The very specific and scientific description of what goes on at the Hadron Collider.
Looking for the Higgs version.
Prime, come in.